So, good evening everyone. My name is Badal Ramteke, a third year BTech student from Kids Ramteke. So, I am here to explain a topic that is RAG. It's getting very famous amongst developers and all, and the full form of it is Retrieval Augmented Generation. So, why it is developed or invented? Okay, so the problems we were facing before RAG, that LLM means large language models like ChatGPT, Claude, and other models, like there are different type of model, DeepSeek and other. Okay, so the main reason for it was AI use it to hallucinate a lot. Means, like if you give him a prompt, then it has loose and context. But the main issue was it was trained on a dated data. Means it was trained on data that is not up to date, not too much old. So it was trained on a data till a date. So if you are a company or a developer who wants a recent information, but AI does not have, because it trained on a data that till a date. So to get an data or get an good output, you will tell like that is, but AI starts hallucinating, it gives something else. So for that reason we use the retrieval augmented generation. So to get the basic idea, like we first, it what does is it does the storing thing. So the documents, raw documents, are stored in a vector database after doing embeddings. Embeddings mean numbers with meaning. So it is stored in vector databases like Pinecone. I have used it in my one of my projects. Then what we does, after storing, we retrieve it. So after storing it, we give a query. That query also is converted into a embedding number with meaning. Then it is used a similar search. So whatever the vector means the numbers, and we will go more deep in this topic. Okay, so embedding, it compares which is similar value. Like in question there is a pen, suppose there is a pen in query, what is mean by pen, and our document also is about something pen. So in vector databases we have stored numbers. Means after doing embedding, that pen is also converted into an that pen also is converted into an embedding, that means vector, and that vector has some values like pen or number that related to pen. So when we do query, that the query also get converted into the pen, and they are similar, so it search the similarity. Okay, so it goes to vector database, search that thing, and get the chunks. What is chunks? When we do the embeddings, the our document is converted into the small chunks. Like there are 200 pages of PDF, and so we convert that into chunks and upload it by doing embeddings, means chunk wise, and that chunk also converted into the vectors. Okay, so that is the whole process. And all the after getting the similar values, we give the give the question means query, and the context means chunks. Whatever we get from our search, we give that context, and user prompt means prompt construction, and give to the LLM. He gets context and what to answer, then he answers it, and this is our process done. Okay, now to go more deeply in Rex architecture, here we go. Like first, we get raw documents, PDFs, docs, and Excel. I think Excel and other document types. Okay, other document types. Then what we do is we start text parsing, or you can say chunking, where we use an chunker like lang. Sorry, we first load documents. Okay, using langchain loader. Using langchain loader. Okay, what it does means it loads the documents. Okay, then we use text parser or chunking to chunk all the document. So we use chunking, like there is a tool of OpenAI, we use that for chunking. It is called something embedding small, something like that. I don't remember the name. I can see it, it's in a book, but I am practicing communication, so let's forget it, just explain. Okay, so we do the chunking. What There are two types of chunking. Okay, so chunking is the really most important process here, because good chunking gives you good results. So if you get good output, means if you give good input, you will get good output. So there are two types of chunking. First is fixed, where we do like 500 tokens, means, or you can resemble as a 500 letters or words in a chunk, and 50 overlap, means like you can assume this as a 500 chunk, but when we make like another 500 chunk, like this is another 500 chunk, the edges that have information, they missed, means they are gone. So what we does, that we get 50 chunks from here, 50 chunks from here, so information should not get lost, and we do the embedding. So the another part is semantic semantic chunking, where it is smarter approach than the fixed chunking, where we chunk based on the paragraphs and meanings. So it is smarter approach. Then we store that in a vector database like Pinecone or what. Okay, so what is a vector? Means we convert vector into vector. Okay, so what is vector? Means it is a meaning embedded in a position. Okay, means meaning is embedded in a so it is a suppose it is a mathematical space, whole space. Okay, so meaning of a word is embedded in a position coordinates in that mathematical space. So similar meaning words are closer, like if I am doing it's ML and it's AIML, so they are close. But if I am doing ML and there is a pizza, it will be in mathematical space, it will be very far away from it, cause it's not related. But AIML and ML is related, cause ML is a superset of AI, sorry, subset of AI. So the so after getting the positional encoding, sorry, it's transformer topic. after getting means after outputting into the vector database, what we do is so what we do after then we run query, means now you will start the second phase. In the second phase, user give a query, that query also get sorry okay wait a minute, sorry, I messed up everything. I forget what I learned about the rag. So like I will go because I don't want to see, so I go with the flow. Now what it does, after ending embedding of that vector chunks into the vector database, what we do is it so what we do is for search we use um, for search we so uh, means yeah, sorry, we the to search and query with the vector. So now we will start second phase. In the second phase, the user starts a query, give a query, and the query also gets embedded into vector. Okay, means it also go through a process of embedding, the same process we did with the chunking and embeddings there. After the embedding, we go after the embedding of query, we go to the vector database and we match every vector of query against all the vectors of documents or chunks we have done. So there are like one algorithm used, like the ANN, that is called approximate neighbor nearest neighbor, approximate nearest neighbor, and that consists of HNSM, means hierarchical navigable small world, and another one is IVF, that is called inverted indexed file. Okay, this is the searching algorithm we use. Okay, after that what we does is we compare them all, then we get our input, means our chunks data and the query that match, and we get that. And what we do is now prompt construction, where we include the query, okay, and the chunks we got, means now this query and the chunks we got from that query we embed, means sorry, we create this context or prompt and give to the LLM. So LLM process it and give us the answer. So that was the whole process of it. It have taken like 13-14 minutes, and I have done a lot of fumblings. That is okay. Failing does not give you reason to give up. So now I think I have forget something to tell. I will check here. Prompt re-ranker. Okay. Okay. All things went good. I have forget about re-ranker. Okay. So what re-ranker does? It's a cross encoder model where in industry the cohere re-ranker is used. So what it does is when we get data from vector search, it is roughly related to the query, but in the re-ranker what it does is it will create, means it will give you the uh, it will give you accurate result. It is slow but it gives accurate result if the vector search is finding 20 candidates. so the re-ranker will find only 5 that is accurate and perfect for that. So it is good, and there are many things like it is used in various applications. It has various applications. So that's for now. For now, that is for now, and now we will failure. It has also failure plan, but tomorrow we will cover something vector database and something like topic. So bye. We will meet tomorrow.